First, we're going to look at our steps. So step 1, you're going to use the smallest denominator. Make a list of multiples for that number. In your question, you're going to have 2 fractions. Next, you're going to keep counting until you find the other denominator in your list. If you don't find it, make a list for the other denominator. Stop as soon as you get a number that is in the other list. So you're looking for your list to have the same number. Count to see how many times it took you to get to that number. That is your factor. You will multiply the denominator and numerator by that factor to make an equivalent fraction. You're going to repeat step 5 for the other fraction if you had to make a list for it. Now, both fractions should have the same denominator, and you can just look at the numerator to see which is bigger. If your fractions already have the same denominator, then there's nothing for you to do. You just look at the numerators and decide which one is greater and which one is less. So let's practice. Okay, I have 2/3 and I have 1/6. I check my denominators. 3 and 6, they're not the same, so I have to do some work in order to decide. So I'm going to take my smallest denominator. Remember, denominator is located at the bottom. So I want to skip count, or I want to list my multiples for 3. So I have 3. What comes next? 3 times 2 is 6. And I could keep going, but again, the purpose of your list, you're trying to find where you can have the same denominator. So as soon as I wrote that my next multiple down, I see that I can change 3 into 6. 3 is a multiple of 6. So how did we make 3 become 6? I have 2/3, and I see that I want my new denominator to be 6. Okay, so I can multiply 3 times 2. Whatever you do at the bottom, you want to do it to the top. So times 2, because I have to have a whole fraction in order to make an equivalent fraction. So you have to use the same number. So what is 2 times 2? 2 times 2 is, 4. So now I'm comparing 4/6 and 1/6. Remember your greater than, less than, and equal to inequality symbols. So 4/6 and 1/6. Now that I have the same denominator, means they come from the same whole, I can just look at my numerators. So 4 is greater than 1. So therefore, 2/3 is greater than 1/6. Let's try another one. Remember to press pause and try it yourself, and press play to check your work. Now I have 6/8 being compared to 2/4. They're not the same denominator, so I have to do some work here, make them the same. So I'm going to use the smallest denominator, 4, and I'm listing my multiples. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. But I can stop because I was able to make 4 become 8. And I already have 8 in my other fraction. So I don't have to keep going. So let's change 2/4 to have the denominator of 8. How do we do that? I can say 4 times 2. Whatever I do at the bottom, I need to do it at the top. And they have to be stacked on top of each other so that I see that I have a whole fraction. So 2 times 2 is 4. So now I'm looking at 6/8 being compared to 4/8. Now that they have the same denominator, meaning that they come out of the same whole, I can decide 6 is greater than 4. So therefore, 6/8 is greater than 2/4. Try another one. And I know most of us, we like the butterfly method for comparing fractions. However, as you get ready to go into adding and subtracting fractions, you can't rely on the butterfly method And those of us that do know what to do after you multiply those two, make those two multiplications cross, when you get older, some of us do know what to do after that step, but still, when you get to fifth grade and you have to simplify fractions, fifth and sixth grade. Multiplying what you have, those denominators are going to become really big in sixth grade and fifth grade, and you might have a hard time trying to simplify those big numbers. So making equivalent fractions will help save you some hard work later on down the road. So now I have 1/3 and 2/5. I need the same denominator. So I'm going to skip count. I have 3 times 1 is 3. 3 times 2 is 6. 3 times 3, 9. 3 times 4 is 12. 3 times 5 is 15. And I tell my students to just stop when you get the fifth multiple, just so you can go ahead and keep working. You don't want a long list of numbers down your paper. 5, 10, 15. Oh, I can stop. I found the same number in both my lists. And then I had a student say, well, can I just multiply the two denominators together? Yes, you can do that as well. But again, once you get to fifth and sixth grade and you have to simplify fractions, just multiplying them together, sometimes you're going to come out with a bigger number than you actually need. And you're going to have to break it down to the smallest that it can be. So if you start with a list and pick your first numbers that you have that's the same, then you'll start in your smallest equivalent fraction, and you won't have to simplify that much later on. Okay, so my new denominator for both need to be 15. Okay, and so now I want to know 3 times something equals 15. 3 times 5. And if you're not sure, that's why you show your work and make your list. You can just count 1, 2, 3, 4, 5. It took me to get to 5 in order to reach 15. What I do at the bottom, you do at the top. So my new numerator for this fraction is 5. Come over here to 2/5, and I'm trying to say 5 times something equals 15. 3. What you do at the bottom, you do at the top, right on top of each other. So 2 times 3 equals 6. So now that I have the same denominator coming out of the same hole, I can just look at my numerators and I see that 5 is less than 6. Therefore, 1/3 is less than 2/5. Next one. 5/8, 5/6. Now you may say, oh, they're equal. They got the same numerator. No, having the same numerator does not help us figure out which is greater and which is less. We have to base that on the denominators first. So start with my small denominator, which is 6. Skip count by 6. 6, 12, 18, 24, 30. Sometimes you may have to keep going, but like I said, just to get you started, you can stop on the fifth one so you can go ahead and make your other list. All right, now I have 8, 16, 24. Oh, I can stop. I see 24 and 24. Okay, so 5/8 new denominator will be 24, and 5/6 new denominator will be 24. Now let's see how we can get there. 8 times something equals 24. Again, if you're not sure, look up at your list, and it took us 3 numbers to get there. So 8 times 3, what I do at the bottom, do at the top. So 5 times 3, 15. Come over to my 5/6. I have 6 times something equals 24. 1, 2, 3, 4. What I do at the bottom, I do at the top. 5 times 4, is 20. So now that I have the same denominator, now I could just look at the numerators. 15 is what compared to 20? 15 is less than 20. So therefore, when I look back up at my question, 5/8 is less than 5/6. All right, look at this one. Oh, what do you notice? I already have the same denominator, so I don't have to do any extra work. Just look at your numerator. 7 and 2. 7 is what compared to 2? Greater than. Remember, your symbol always opens to the biggest number. So you didn't have to do any work for that one because your denominators were already the same. The only time we're making those lists of multiples for our denominator is to have the same denominator. So if they're already the same like we have here, there's nothing for you to do but look up at your numerator and go from there. If I was doing adding and subtracting fractions, then since they're already the same, then you would just go ahead and add or go ahead and subtract. All right, look at this one. 13 hundredths being compared to 2 tenths. Okay, so now if you're good with your multiplication facts, you will already know that 10 is a multiple of 100. So you can save yourself some time. You know that your new denominator will be 100. So how will we get there? 10 times what give us 100? 10 times 10. And what I do at the bottom, you do to the top. What's your new numerator? 20. So now you're ready to, 22 looking a little funny there. Now you're ready to decide which is greater, which is less. So I have 13 hundredths, 20 hundredths. 13 is less than 20. So 13 hundredths is going to be less than 2 tenths. All right, next, again, be sure to press pause, try it yourself, and then press play to check your work. So I have 5/3 being compared to 4/10. 3 and 10. Again, if you know your multiplication facts, then you know that you can come up with 30. But if not, just work it out. My smallest denominator is the 3. So I have 6. Then I have 9, 12, 15, 24, and 30. And then here I have 10, 20, and 30. So we stop as soon as we get the same number in both. So my new denominator for both fractions will be 30. And now I'm ready. And remember, so I did have some people, they found the new denominator and then they kept the same numerator. However, remember what we say, whatever you do to the bottom, you do to the top. So if my bottom number changes, my top number has to change. Think about it like this. If you go shopping and you want your mom or dad, whomever, to buy you a new outfit, do you just want a new pair of pants? Or do you want a new pair of pants and a new shirt, right? So we want both of them to become new. All right, so how do we make 3 become 30? 3 times what? 10. Whatever I do to the bottom, I do to the top. So what's 5 times 10? 50. 4 tenths. How do I make 10 become 30? Times 3. Whatever you do at the bottom, you do to the top. And so my new numerator is 4 times 3, 12. So now I'm coming out of the same hole because I have the same denominator. So 50 compared to 12. 50 is larger. So therefore, since 50/30 is my equivalent fraction for 5/3, that means 5/3 is greater than 4/10. Okay, next. So let's check your work. We have 6/8 compared to 3/4. Again, if you know your multiplication facts, you can save yourself some time. You know that 4 is a multiple of 8. I can make 4 become 8. How? 4 times what would give me 8? 4 times 2. What you do at the bottom, you do to the top. So what's 3 times 2? 6. Oh, look at here. 6/8. Again, if your other fraction already has the denominator that you need, you do not have to do anything to this other fraction. It already had an 8, so it should stay the same. So 6/8 compares to 6/8. That means they are equal. Okay? So that's why it's important to have the same denominator, because if I look at 6/8 and 3/4, totally different numbers just by looking, of course, unless you know your multiplication facts or knowing that 3 is also a multiple of 6, like 4 was a multiple of 8, then you wouldn't be able to tell that they were equal unless you draw a picture. So making the same denominator is very, very important. All right, and then sometimes in these comparing questions, they'll throw in for you to put your fractions in order from least to greatest. You're doing the same steps. It's just instead of 2 fractions, you have 4. I mean, I'm sorry, 3 here. You could have 4. You could have more than 4. But you doing the same thing. I want the same denominator. So start with your small number. I have 2. And I'm going to skip down here not to cover up my words there. So 2, 4, 6, 8, 10. Oh, I got 10 there, so I can stop that one. Let's see if I can get 10 with my 5. 5, 10. Oh, I can stop. When you have more than 2 fractions, all 3 have to be working with the same number. Okay? So 2/10, I already had a 10, so I don't need to do anything to that one. 1/2, I want to change that to 10. And then the 3/5, I want to change to tenths as well. Okay, so looking at 3/5, how did you make 5 become 10? 5 times 2. What you do at the bottom, you do to the top. 3 times 2, 6. Okay, then 1/2. My 2, what did you multiply 2 by to get 10? 2 times 5. What you do at the bottom, you do to the top. So 1 times 5 is 5. Again, I don't have to do anything to 2/10 because it already had a 10. Now that everything is the same, the denominators are the same, they're coming out of the same whole, and that just means all of them are the same sizes. If I draw a picture, all of them are the same size. So I could tell least to greatest. So my smallest numerator here is 2. So 2/10 will come first. Then I'm looking at 6 and 5. 5/10 will come next. And then 6/10. But now I need to use the original fractions from the question, because your answer choices will be using the original fractions from the question. You won't see the ones that you created. So let's redo this. 2/10, okay, that was an original fraction. I said 5/10 come next. 5/10 was originally what? 1/2. So 1/2 would come next. And then 6/10 was originally what? 3/5 from the question. So 3/5 would come next. Okay? You might want to rewind that one and try that one again. All right. So here are you some practice problems so you can keep practicing. Rewatch the video as much as you need so you get familiar with the steps. And I hope this video was helpful. Thank you.